This is the RC Arduino powered Tamiya Sand Scorcher. I'm just going to take the top off and show you the Arduino inside the Sand Scorcher. Just get the shell off here. And you can probably make out the green glow coming from this area of the car. That's the Arduino telling us that it's on, and there's actually a red warning light on in there as well, telling us that there's no RC signal. So what I'm going to do is I'm going to take this out of the car and I'm going to show you how it's powered inside the car, how it connects to the receiver, and how it actually connects to the electronic speed controller and servo inside the car to give us full control of the car through the Arduino. So I've taken the top off the car, which is this piece, and moved some of the wiring out of the way so we can get a much better view of the Arduino. I'm now going to zoom in and look at how it's actually connected within the car. The Arduino inside the car is a very ordinary breadboard Arduino. It's an Atmega 328 with the Arduino bootloader. There's a 7805 regulator taking power in from the LiPo battery inside the car through this connection, which goes into the balance plug of the battery. That's then supplying the 5 volt to the Arduino chip. It isn't supplying the 5 volts to the servos. That's actually coming from the electronic speed controller. The electronic speed controller has a battery elimination circuit which comes in through this connection here, and that's then connected directly out across a power rail at the bottom here to the servo and to the throttle. The signals to the servo and the throttle are actually coming from the Arduino though, and they're connected here and here to pins 8 and 9. A quick word about the 3 indicator LEDs before I start hooking things up. This is simply a power indicator, the green light. The red light tells me that I've got an error, and the yellow light tells me that I'm entering child mode. The reason for me building this circuit in the first place is so when I go out with my son, I can hand him the controls and secretly switch the car into child mode, and it's going to slow down to about a quarter of its normal speed. When he gives the controls back to me, then I can send a signal and the car will return to full power for me to use. The RC channel signals are coming into the Arduino through this receiver, which I've actually hacked. So instead of using the channel 1, 2, 3 individual outputs here, I've added this additional wire with a jumper on the end, which has access to the PPM signal within inside the receiver. So I'm getting all of the channel information through a single signal, meaning I can use a single interrupt rather than 3 interrupts to read the entire signal. There's full information for how to do this on the RC Arduino blog, with an example on this receiver and another Futaba receiver. This is a high-tech receiver, showing how I hacked both receivers to access the PPM signal through this single connection. There's also the full source code for using this hack as well. I'm just going to use the Sand Scorcher body shell here to place the circuit on while I build the circuit up so we can see what's going on. The Sand Scorcher is a 30-year-old design which has been re-released recently by Tamiya, and I've taken some effort to paint the shell to look like a 30-year-old Baja bug. As you can see, I've put lights, rust on the lights, faded the decals and so on. But for now we're just going to use it as a table to hold the circuit. Here's the back end of the Arduino. You can see that it's actually attached to the car just through normal double-sided sticky tape. So I'm going to place that there, and the first connection I'm going to make is to supply power to the Arduino. So I'm going to connect this 3-pin header into the balance plug of my LiPo battery. Now I've got a diode before the regulator, so if I attach it the wrong way, the diode's going to save me from any damage that I might get from reverse polarity. You can see that as the circuit started up, the LEDs cycled through a sequence to tell me that the Arduino is reset. That's a useful feature to have in your projects, just so you can see if for any reason you're running low on power and the system resets. The next thing we can see is the red light is on. The red light's telling me I've got a problem, and the problem is that the receiver's not attached and I'm not receiving any signal. So now let's attach the receiver. To do that, the first thing I need is power for the receiver, and I'm going to take that from my electronic speed controller. So most electronic speed controllers provide what's called a battery elimination circuit, and this is my power plug that comes from the battery elimination circuit in my electronic speed controller. So I'm going to connect that into the battery socket here. On receivers, the negative side or the negative cable is always on the outside, so always connect the negative to the outside. I haven't found any receivers yet where the negative is not on the outside. So ordinarily we'd have to connect 3 more cables into here and find 3 interrupts on our Arduino to read the 3 individual signals. As I mentioned, I've hacked this so as we're getting a single PPM signal out through this one connection. So I can now attach that directly to digital pin 2, which is our Arduino external interrupt number 1. So we're just going to use that single interrupt to read all of the information. So at this point I've got power coming from the balance plug of my LiPo battery into my breadboard Arduino. I've got power coming into the receiver, and I've got the hacked PPM signal coming out of the receiver through this wire into an interrupt on our Arduino. So in order to get control of this car, the next thing I need to do is to connect up the electronic speed controller to receive a signal from the Arduino, and also the steering servo over here to receive a signal from the Arduino. To do that, I've soldered in some servo extension cables onto my Arduino breadboard. These are connected to digital outputs of the Arduino, which I'm driving using a servo library. So let's connect the speed controller. Speed controllers work just the same as servos, so you can use the servo library to drive them. Let's just make sure I have it the right way round. Yes, that's the throttle signal. Now let's do the steering signal. So both of these are being driven through the Arduino servo library. They're actually being driven through the RC Arduino version of the servo library, which gives you a little bit more performance and allows you to use timer 1 for RC timing code. So it's a bit faster, a bit more efficient, and should lead to smoother projects. I've got one last connection to make, which is one that you could easily forget. Although the receiver has power, which is coming from the electronic speed controller, and the servo is plugged into the Arduino, there's no power going to the servo at the moment, because ordinarily all of these connections within the receiver share a common power bus. All of these ground pins on the right hand side are actually connected together if you take the case off the receiver. You'll also find that all of the center power pins are actually connected together as one common power bus. So when power comes into the receiver, that same power would normally go out and feed the servo. In this particular circuit, we don't have that option. So what I have over here is a connection which allows me to connect the common power rails on my Arduino here into the receiver and share that power that's coming into the receiver. So power is coming from the speed controller battery elimination circuit into the receiver, where all of these power pins are connected together internally. So I'm then taking that power out from the receiver and sharing it across a power bus here, which goes to all of the RC channels, so all of my servos. So that power is coming out through here and out through here. Now with all of these connections in place, I'm ready to switch my transmitter on and take control of the car. So let's switch the transmitter on. That's now on. Now if I switch the car on, what you'll see is this red light will go off, indicating that the receiver's got power and a signal is coming into the Arduino. If I lose the signal for any reason, that light will come back on and the Arduino will enter a fail-safe mode. But for the moment, let's just switch the car on. What you should also hear is the electronic speed controller will emit a sequence of beeps to indicate that it's found the signal it requires to arm, and it's armed and now ready to drive. So let's do that. And there you go. I now have control of this car through the Arduino. There is no direct connection from this receiver into the car. All of the processing has been done on the Arduino. So let's just demonstrate that quickly. So that's throttle control, and there you can see that I'm moving the steering servo. Now, one of the reasons for me building this circuit was to implement an additional mode in this car, which is child mode. And if I move the transmitter slightly, you'll see the yellow LED come on, indicating that I'm in the zone where I can activate child mode. When I activate child mode, the car's power is restricted to about 25-30% of the normal car power, and I can hand the transmitter to my son. But there you go, that's a run through of connecting an Arduino to an RC car. Now let's